is Alice in Wonderland for anybody who's a Newtonian. Letting go of Einstein, letting go of space-time was a bigger leap, for Alice than the leap from Newton to Einstein. This, letting go of space-time altogether is a leap too far for most people in my generation. But I think the younger generation that spend time in the metaverse and have spent a lot of their life in the metaverse, and it will not be a big leap to think, well, when I take off my headset, maybe I'm still inside a headset. So we could talk about that, absolutely.
Yeah, absolutely. That would be excellent. I guess the best place to start is generally we associate, I think, when we talk about consciousness with a brain and an agent that acts in the world, and that's a prerequisite to consciousness. And so I think maybe sometimes it's hard to get out of that schema and into a schema that's more of consciousness as the container for agents. And you talked about Markovian dynamics and Markov, like an ultimate Markov blanket by which we could exist within, permits consciousness to be kind of an integral component of reality. And I guess my question to you, I guess to start off with that is do you see consciousness as something fundamental and something outside of just a product of the brain and computation?
I do, and one reason why I've moved in that direction is because our best science tells us that space-time is not fundamental. So physics, in particular quantum field theory, together with gravity, tells us that space-time is not fundamental. They're looking and finding structures beyond space-time that actually are able to predict scattering process amplitudes, like in the Large Hadron Collider, and these are structures beyond space-time. So we're in a situation where our best science, in the case of physics, is quantum field theory and gravity, is telling us that space-time cannot be fundamental, and therefore particles in space-time, quarks, gluons, and bosons, which we've taken to be elementary particles. Sorry, quarks, leptons, and bosons. I think I misspoke. Quarks, leptons, and bosons are we think of them as fundamental particles. But if space-time isn't fundamental, then those particles aren't fundamental, because from a technical point of view, particles are nothing but representations of the symmetries of space-time, so-called Poincare group of symmetries of space-time. So if our fundamental particles are just representations of space-time and space-time itself is doomed, then the particles are not fundamental. And that's the problem with panpsychist views, right? They're trying to put consciousness inside the particles. Well, the physicists are telling us that space-time is doomed, so the particles are not fundamental. So the panpsychist might as well be sticking the consciousness inside earth, air, fire, and water, because that's not fundamental either. So the panpsychists like to argue that we can inherit all this wonderful structure of the laws of physics in space-time, but the physicists are telling us that those laws of physics in space-time are a projection. They're a shadow of a much deeper dynamical, or whatever it might be. They don't know what it is beyond space-time. They're finding these static structures. They're not finding something dynamical yet. They're just finding these polytopes. So that's one reason why I am disinclined to take consciousness as a product of anything inside space-time, because the physicists are telling us that anything inside space-time isn't a fundamental reality. It's a shadow of some deeper reality. And then my own work with my wonderful colleagues and graduate students on evolution by natural selection. That's another pillar of modern science. I would say those are the two big pillars, evolution by natural selection and quantum field theory with gravity. Those are the big pillars. Evolution by natural selection agrees with the physicists that space-time is not fundamental, but it comes at it from a different angle. It's saying that our senses don't show us the truth. Our senses show us space and time and objects. That's what they show us. But evolution says what you're seeing is not the truth. It's just a user interface, effectively. Put it this way, what it strictly shows is that whatever you're seeing is just a guide to adaptive behavior. That's what it is. It's not the truth. It's a guide to adaptive behavior. And to understand that, I think it's best to think of it as like a user interface. A user interface is a guide to adaptive behavior in some computer system that you're trying to operate or whatever. So it's not like I'm saying I don't like the physicalist stuff, and for religious reasons, I think we should start with consciousness. It's not that at all. I'm saying our best science tells us that we're fools if we start with something inside space-time. We're just fools. That's a shadow of some deeper. We're just as much fools as if we started with earth, air, fire, and water. So that's why I'm not doing it, because our best science doesn't tell us that consciousness is fundamental. So I should be very careful about that. It tells us that whatever is fundamental is not inside space and time, and it's not space, time, and particles. So it's a leap on my part, a leap beyond the current science to say, okay, well, I know I shouldn't start inside space-time, so let me start with something outside space-time. And since I'm trying to understand consciousness, and I can't start by booting up consciousness from inside space-time, I'll start with consciousness itself outside space-time, which is sort of a trick, right? You have to start thinking about entities existing and interacting outside of space-time. And you might say, well, I can't do that. Well, it turns out you can. It's just that you have to be flexible cognitively and start to, and it helps, the mathematics really helps you to start to consider things beyond space-time. So yes, so the answer to your question is yes, I start with consciousness, but not willy-nilly and not for any religious reasons, or I do it simply because our best science says don't start inside space-time. And that really rules out all physicalist, functionalist theories. You might say, well, it doesn't rule them out because they don't assume space-time, and it is true. I mean, you could have a functionalist theory of consciousness and say, well, it's instantiated in angels instead of in neurons or particles, but no one goes there. So, I mean, and this is a question that Dave Chalmers asked me a couple of weeks ago at a workshop. What about functionalist approaches? And my attitude is that, strictly speaking, functionalism doesn't require space-time. So you could say functionalism is ruled out by space-time being not fundamental. But I would say this: everybody who proposes a functionalist theory of consciousness believes that it's a function of some objects inside space-time, and they would be very unhappy to realize that they have to give up space-time. They would not want. So functionalism was a way to get rid of the particular instantiation in space-time, but not to get rid of space-time. So basically, what modern physics and evolutionary theory is telling us, all physicalist approaches are wiped out. Panpsychists are wiped out, the ones that take particles as fundamental. The functionalist ones are wiped out because, not because they assume space-time, but in principle, but in practice, everybody who puts out a functionalist theory wants it to be a function of something inside space-time. So, and then I'm not, strictly speaking, an idealist, partly because, and I don't use the term idealist very often, because idealism has a lot of different versions, a lot of history, a lot of baggage, and sometimes an anti-realist approach, and even an anti-science aspect to it. So I didn't want any of that. So I call the approach that I'm taking conscious realism. Can't hear you. No audio. Yeah, no audio. Nothing yet.
I'm sorry, yeah.
Now,
yeah, I think as well, kind of touching on that, the problem of emergence was one that.
Yeah.
Oh, sorry about that.
Now I can hear you. Yeah. Now I
Are
can
you
hear
now?
you now. Yeah.
All right. Sorry about that. My connection was getting a little bit spotty. But to further what you were saying, a lot of the intuitions that I had that kind of led me to the idealistic side of things is the issue of emergence of consciousness from inorganic matter, or like you were saying, just the simple reorganization of inorganic matter into a complex entropy defying system. So as I made that leap, it seemed to be, okay, well, if emergence is kind of not the answer, because it seems like it doesn't fit the fit the bill for something as complex as consciousness. When you get down to it, if it's something that can't emerge just from the rearrangement of simple atoms into life, then is it most fundamental to the universe, essentially? And as it gets to that perspective of the panpsychism, panpsychism implies a duality, essentially, still, of a conscious carrying particle or an exchange of consciousness between the agent and what's being looked at. And at that point, it becomes almost impossible for it not to be anything but preceding to matter, to me. Like the qualities coming from quantities as opposed to the other way around. It seemed to me like maybe quality of experience precedes matter, in a way.
Right. So there are various versions of panpsychism, but one of the most well known right now is the panpsychism that Philip Goff and is working on, and there he's very, very clear that he doesn't view his approach as a dualist approach. It's like a neutral monism, perhaps, a Russellian neutral monism or something like that. But what he's doing is saying we have the laws of physics, which govern the behavior of microphysical particles at subatomic scales, and those laws of physics tell us functional properties, but they don't tell us what these particles are at their core. What is it that's obeying all these laws? What is it? Right. So there's something obeying the laws. What is it? And he's saying it's consciousness. So he doesn't want to be a dualist. It's not like a separate realm of so there's space-time, which is physical, and then there's a separate realm of consciousness. And he's saying, no, I'm sticking the consciousness right in in where the particles are, and basically the laws of physics are how consciousnesses interact. So it's non-dualist in that sense. And my attitude again toward that is that if we knew that those laws of physics were the fundamental nature of the laws of reality, then this would be a beautiful and appropriate way to try to think about consciousness. Why not? But when our best science tells us that those particles are just representations of the symmetries of space-time, and space-time itself is not fundamental, then I would abandon that like a hot poker. I'm not going to touch that. It's like, why should I waste my time trying to get a theory of consciousness booted up from something or identified with something that I know is a shadow of some deeper reality? And it's not just a hand wave on the physicists. They're showing us they have new structures in this deeper reality, like the amplitude-hedron and the cosmological polytope. What's interesting about this, it's not unusual in the history of science that this kind of thing happens, right? So there are physicists, and these are not like, some minor physicists at some second-rate university who have some crackpot idea. These are the best and brightest that have been brought to the Institute for Advanced Study at Princeton. So these are the guys that are really, so Nimar Kani-Hamed, Ed Witten, Nathan Seiberg, and so forth. These guys are all saying space-time is it's over, and they're finding new structures like the amplitude-hedron and cosmological polytopes. So when these guys are saying that space-time is doomed, it's a really serious pronouncement. But I was just at a workshop with a number of quantum physicists just a few weeks ago at Chapman University on mind and agency, and gave a talk there. And I asked several of them, of these quantum theorists, what they thought about the work that's being done, showing that space-time is doomed and showing that there are these structures beyond space-time. And in particular, that according to this new research, quantum theory itself is not fundamental. Quantum theory and space-time must arise from a deeper structure. So, and not one of the quantum theorists knew about this work or had any real understanding of it. So we're in it's, and these are the theorists who are being brought together to talk with cognitive scientists and philosophers about consciousness. But even these physicists themselves are really not up on the fact that space-time is doomed. So we're in this interesting position where it's very much like the time between 1905 and say 1925. In 1905, some unknown nobody in a patent office in Switzerland published an article. And with that publication, it was over for Newtonian space and time. It was over. It was Einstein's theory of special relativity, and that was it. But from 1905 to 1925, that's 20 years. It was not well adopted. In fact, in 1922, when Einstein got his Nobel Prize, the committee was very clear that it was not for relativity theory, general or special. It was for his work on the photoelectric effect. So all these brilliant physicists from during that time who were continuing to work on tough problems in physics, like the black body radiation, violating the predictions of Newton, and Michelson-Morley experiments violating the predictions we would get from Newton and the notion of an ether. It doesn't matter how smart you are. If you're trying to do it within a Newtonian physical framework, you cannot answer these problems. You can't solve them. The amount of genius is irrelevant. You have the wrong foundation. And so we're in the same position right now. My colleagues who are studying consciousness, many of them are just absolute geniuses. I know many of them personally. They're good friends or colleagues, and they have IQs out the wazoo. But they're like the Newtonian physicists of a century ago, literally just a century ago, who were trying to solve these problems with the wrong foundations, and that's where we are right now. So my brilliant colleagues have beautiful theories based on the idea that space-time is fundamental, and physics of particles is fundamental, and that's over. And the sooner my colleagues can let go of that, the quicker their brilliance can be unleashed on real solutions to this problem of consciousness. So that's why I'm harping about space-time is doomed, and we need to let go of the physicalist stuff. Not because I have anything against space and time. It's just that our best science tells us there's something deeper. So we're going to understand space and time, or space-time, as an interesting projection, but one of just many, many possible projections of a much deeper reality. And so the race is on to understand what the deeper reality is. And the horse I'm riding is saying, well, maybe it's if we can get a mathematical model of consciousness. And this mathematical model of consciousnness, which would be in some sense dynamical, maybe it can show where these structures like the amplituhedron and the cosmological polytope, these structures, so the physicists are starting with space-time, they're looking beyond space-time. Their flashlights are going into the dark beyond space-time, and they're finding these geometric objects that are just sitting there. So they're like, tetrahedra, and they're not literally tetrahedra, but think about, just to get some concrete image, there's these big cubes and tetrahedra and all these little, they're out there. So they're out there, but there's no notion of process, and who ordered that? Why are these things sitting out there? But somehow these things give all the information, they project down to space and time and unitarity, which is the quantum theory. So why? So if our theories of consciousness can go deeper than the amplituhedron and the cosmological polytope, if we can actually have a process theory and show that somehow a projection of that process gives us these polytopes, these geometric objects, then we have a way of starting with consciousness, and without waving our hands and wishy-washy stuff, we go straight from a dynamics of consciousness through its long-term behavior of the consciousness, through permutations, through the amplituhedron into space-time. That's, I think, the way forward for a science in which we understand space-time and consciousness and their relationship, and we perhaps reverse the relationship where we thought space-time was fundamental and consciousness emerged, and we now switch it around. We start with the dynamics of consciousness and show that space-time is merely a particular headset, a particular interface that some conscious agents use to grok their interactions with some other conscious agents. But it's just, space-time is just one of countless headsets that could be used, interfaces that could be used.
Wow. Yeah. No. That and like you had said, that's kind of an inversion of the current physicalist view, like you were saying. And the philosophy of science, if anything, it's shown us over time that probably what we hold as fact today in 100 years, if it were to follow the same patternistic flow, we would overturn many of the things we hold to be factual today in 100 years. At least looking at just even the simple denial of tectonic plates took forever for that to infiltrate, and become accepted. And so I think there's to your point, it's a tall task, I assume, in academia to get people on the ship of this thought, simply because of it being inverting the typical matter preceding mind in that framework.
Yeah, yes, I think my generation won't do it, but the younger generations are always the one that have the flexibility and the energy of youth to take on that challenge. And so I think it will eventually become the mainstream that space-time is not fundamental. Quantum theory, as powerful as it is not fundamental theory. There's something deeper, and the deeper stuff is what surprising the physicists actually is that the deep structure behind the amplituhedron and the cosmological polytope, to their surprise, is something called permutations, which it seems almost trivial. If I have like three numbers, 1, 2, 3, there's 6 permutations. It could be 1, 2, 3, 1, 3, 2, 2, 1, 3, and 2, 3, 1, things like that. So how could something as drop dead simple, you would think is drop dead simple as permutations, capture all what they call the physically invariant information in these structures, but it does. And so the challenge, and it's something I'm thinking about and have some thinking about this morning, was taking the dynamics of conscious agents and mapping it onto something called Birkhoff polytopes, it turns out that the Birkhoff polytopes, all of their vertices are permutations. So it's this big convex structure that and it has faces and edges and vertices on it, like a cube, right? The cube has 8 vertices, I don't know how many edges, and 6 faces or something like that. So these are higher dimensional objects with all these vertices, faces, and edges, and each vertex is a permutation. And so what I was working on this morning, in fact, before we got on, was a way of mapping the Markovian dynamics of conscious agents onto the Birkhoff polytope in a way that preserves the actual flow. So the flow of the dynamics is far more general. It's in the Markovian dynamics of conscious agents is in a much bigger space than the corresponding Birkhoff polytope that's in that space. But there is, I'm looking at canonical ways to project onto that Birkhoff polytope, which gives you, all the information of permutations and convex combinations of permutations, and that then is precisely the physically invariant information that's captured in the amplituhedron and so forth. So that's why I'm spending my time going in that direction. But you can see that this is a completely different way of thinking about consciousness, right? Where it's almost everything that we've been thinking, it somehow emerges out of unconscious, simple physical ingredients. That whole approach of reductionism, physicalist reductionism in space-time, which has been so powerful, even that approach has to be dropped. Physicalist reductionism is dead because space-time is dead. And so this is a real shock to the system. And that's why, even though the amplituhedron's been out for 10 years now, I can 10 years later ask quantum theorists, professional quantum theorists, do you know that space-time has been dead for 10 years? And they don't know it. they don't know. So it's no surprise. And so we're in this situation where the work, 99% of my brilliant colleagues are doing work within the old framework. It's like, literally 100 years ago, a lot of physicists were doing physics work inside the Newtonian framework. They didn't understand that you had to move to Einstein, and then 1925, 1926, that we discovered you had to actually add quantum theory and as well. So that's where we are in consciousness studies, and it's going to be, I think, for historians looking back at this time, it'll be like how we look back at that time from 1905 to 1925 and go, wow, brilliant people wasted 2 decades. of their lives. They didn't jump on to, I mean, if they had, I mean, it's not that Newton isn't interesting, is that if you're asking fundamental questions, Newton isn't the framework for the fundamental questions. If you're trying to do something like, you know, send rocket ships to the moon, Newton's pretty good. It works fine. But for those who are trying to address fundamental questions, why does black body radiation do what it does? Why does the Michelson-Morley experiment make light seem so strange? Newton's the wrong framework, and so I think history will look back at this time, and I don't know how long it'll take for my colleagues in cognitive neuroscience to catch on, but I don't think they'll catch on before most physicists do. So I think what's going to have to happen is that most physicists are going to have to really understand that space-time is doomed, and then the word sort of, you know, the cognitive scientists, you know, have to then take it from the physicists. So I my guess is it's going to take a while, and that means that unfortunately, my brilliant colleagues who have the genius to really push this thing forward will be putting that genius in earth, air, fire, and water, as opposed to whatever is fundamental.
Yeah, no, I understand. Yeah, it's like you said, it's a dramatic landscape shift that, you know, and science has to take time. And I guess, like you just said, your colleagues in cognitive neuroscience, of course, neuroscience is a major component of consciousness studies, along with a lot of other multidisciplinary interactions that are required, kind of, at least even getting into AI. I mean, it seems like almost every aspect, evolutionary biology, all of these fields kind of coalesce at the subject of consciousness. And inevitably, it seems to me that's going to produce this diverse array of definitions and multiple parties and multiple different people in the same study chasing different rabbits, so to speak. Not intentionally, maybe, but that's just if you're defining consciousness as agency here and self here, and then simply as awareness over here, and just so then you have a lot of kind of different paths, it seems like, that are kind of going out different directions, trying to solve the same inexplicable problem. And so I find that kind of odd. And what I wanted to ask you is something that at least I think I had spoken with some cognitive neuroscientists, and what has fascinated me was the orchestrated reduction by Roger Penrose and Stuart Hameroff, understanding maybe that may not be the, you know, the answer. It did seem to yield some insights I wanted to run by you and see maybe, and that's in the subject matter of anesthesia. And I found that an interesting way. Of course, we look at anesthesia as a way by which to interrupt consciousness or remove it or render an organism biologically viable but unable to respond to environmental pressures. So basically still alive but not asleep. And so you get a weird area by which to study this phenomena. And I started looking into research on it and realized that anesthesia can be administered even to the most smallest of bacteria. And anesthesis can still occur at the very lowest prokaryotic level. And that to me yielded something fundamentally insightful to me. And I'm from a non-academic background, so kind of it just came to me as, this is interesting, that if you can disrupt the consciousness of a prokaryotic bacterium, like I guess it would be a paramecium, so to speak. And what they had found was uniformly across the board, from single-celled organisms to something as complex as a human, there was one commonality in anesthesis, and it was the interruption of the microtubule functionality. And so it seemed to me like if we can anesthetize a prokaryotic bacteria, that does bring forth some great insights about, hey, well, if you're going to claim consciousness is emergent, it must not be dependent on a nervous system. At least that must be the case. Because if we're anesthetizing and it's essentially just paralyzing it, but it's rendering it unconscious and still biologically able to be alive. So I was thinking maybe using that platform at least forces, I think, cognitive neuroscientists, maybe not forces, but invites them to maybe assume that even the lowest level bacterium are conscious. If you can anesthetize them, you would essentially be saying consciousness and movement are somehow synonymous all the way down to that lowest level.
Well, I don't know what Penrose and Hameroff would say about that, but here's my thoughts about the whole situation, and that is that the distinction that we make between living and non-living things is not principled.
Yes.
It's an artifact of our headset. So space and time and physical objects are not fundamental. They're just a user interface. And that interface has certain limitations. That's what interfaces are for. They're to dumb things down and simplify them. The distinction we make between conscious and unconscious objects is not fundamental. That is also an artifact of our particular representation, our particular headset, our user interface. And so when my brilliant colleagues are talking about this system is conscious and that system is not conscious, they're making a very deep mistake. There's no difference in consciousness or life. There is a difference in how much the user interface is telling you about what's on the other side. So what they're looking at, so they think that they're thinking that space and time are the fundamental reality and physical objects in space and time are the fundamental reality. They're not recognizing that evolution is telling us that's not the case, and so is physics. So that's not the case. The best metaphor I have right now is to think about it as like a headset. And right now, so for example, I'm talking with you, and I have a bunch of pixels. I've got an interface. It's my desktop screen. I've got a video on there, and there are a bunch of pixels. I see pixels of walls and so forth behind you, and those pixels aren't doing much of interest. They're having a pretty low level of complexity in their activity. But when you're talking and moving your head and so forth, there's quite a bit more complexity in the movement of those pixels. Now, if I say, well, I think these pixels in the middle of the screen, those are alive, and over here they're dead. Well, that's not very intelligent, right? The pixels are pixels, and so there's some pixels that give me insight into your conscious thoughts and your mood and so forth, and there are other pixels that don't. And so when we try to use orchestrated collapse of microtubules or integrated information theory, and we're looking at the properties of the pixels, objects, pixels, and things made out of pixels in our headset of space-time, and we conclude that those are the things that are in fact alive or not, or conscious or not. That's an elementary mistake. And so but you could turn it around. The contribution perhaps of integrated information theory. I'm not saying that they're right, but if there is a contribution from integrated information theory towards something that might be lasting about the nature of consciousness, it may be about the complexity measures in our interface. It may be some way to tell us when our interface is giving us a portal into consciousness. It's giving us useful information about consciousness. So it would be a property, but I don't have high hopes for that either. But that's the best hope I could offer, is that maybe they could be telling us something about the nature of the interface and when it's a better portal to consciousness or a worse portal. But let me say what I think is the potential danger then. So IIT, and it is being used to say, look, if we find a system doesn't have, if a brain system has a high degree of integrated information, but the person seems to be in a vegetative state, we might want to say that they're conscious. But on the other hand, if we find that there's not this high degree of phi or what integrated information, then we can conclude that there's no consciousness. Well, it's not right for me to conclude that because the pixels on your screen you're not moving right now, you're not blinking, you're not doing anything. So I conclude that you're not conscious. Well, and so I could shut off your life support. Well, that's the wrong inference, right? Just because the pixels aren't moving doesn't mean that the consciousness behind it isn't there. So the integrated information stuff being used for biological life and death decisions may not be very, very smart. It may be the wrong thing to do when we realize that that's not telling us about consciousness per se. It's telling us how much we can see about consciousness through our interface. At best, that's what it's telling us. But it's not telling us that there's no consciousness or that there is consciousness. So you can see that this gets out of just abstract, how many angels can dance on the head of a pin. This is getting down to we're trying to use our theories of consciousness to make life and death decisions, pull the plug or not. And I'm saying that those decisions if they're based on the framework of IIT, are based on a false framework, and therefore the decisions that we're making are not principled, and this is dangerous territory. So you can see that our theories of consciousness and this stuff about is space-time doomed or not, this is not just, you know, some academic airy-fairy, you know, who cares. This is, should we pull the plug on your sister who's unconscious and on a breathing tube in the hospital? Is that it makes a difference there, and decisions are starting to be, you know, informed by this wrong idea. So we have to be very, very careful.
Oh, absolutely. That's a interesting point. Of course, I mean, consciousness as a study, it trickles down inevitably to very subject matter of life and death, and measurement scales of consciousness as far as determining patient's brain activity and conscious awareness. So you can properly and compassionately treat patients. So, I mean, like you said, the implications are wide ranging. And so I think the work that's done in the easy problem, as they call it, with the neural correlate of consciousness, they're inevitably never going to yield an answer to the hard problem just by a byproduct of investigatory work, because it's you're like the analogy of somebody's like using EEGs, like throwing a rock down in a well and listening to the echo and then trying to make these strict, you know, this part of the brain is activating this emotional state. And then you see physicalism breaks down even there really quickly, because now I've seen a lot of studies with neurogenesis that have shown the regeneration of pathways in the brain as it adapts as a more dynamic, not so rigorous, static, lobe model of the brain, but a more integrated network of neurons interacting in a dynamic way that can yield, they can repair itself and yield the same things that it may have lost in the past. And so I think they're even defeating the physicalist viewpoint as they investigate it. It seems like.
Well, yes. Are you familiar with the work of Mike Levin at Tufts?
I'm not actually. I've been following Anil Seth a lot, and he seems to follow this easy problem and this idea, but I haven't heard of the gentleman you just mentioned. No.
Yes. So yeah, Mike Levin is a brilliant researcher at Tufts University, working on morphogenesis. How does a single egg with a sperm, a single cell, turn into a human body, for example, in 9 months, and same thing for other animals and plants and so forth. And what he's found is there's a high level control by, believe it or not, bioelectric fields. And when I first heard this, it sounded spooky but he's got clean scientific evidence of these bioelectric fields. It's not his way. I understand what he's saying about it. I mean, I've talked with him. We're friends, and I'm still don't feel like I'm an expert in his work. So I should say that up front, that I would defer to anything that Mike, of course, has to say about his own work. But my understanding is he thinks intuitively about the bioelectric fields is more like the software level, and DNA and so forth, as more like the hardware. And there's this higher level programming language that's being used to control morphogenesis, and in some sense the DNA and so forth is really just the machine code level of things. And so that's an interesting, so I think there's going to be a revolution going forward on that. And Mike and I have been talking, and a good friend of mine, Chris Fields, who's worked with me on theory of consciousness, is also working with Mike. And so it'll be interesting to see how this notion of bioelectric fields and how they seem to be guiding morphogenesis. Again, that's a user interface. That's a space-time representation of things. So I'm very interested to see, is there a theory of, you know, from this dynamics of conscious agents that we're working on, can we show, when we get this projection, how these kind of bioelectric fields appear, and also the DNA appear as different levels of projection of this deeper theory of consciousness. So it's going to be, so there. What happens, as you can see, this changes the game completely. It's much more complicated. It's much more fun. And by the way, I should point out that my theory of conscious agents is limited as well. Right? I'm not saying mine is the final word. I don't think there are any theories of everything. Science cannot give you a theory of everything for principled reasons. There's no principled way to have a theory of everything. Every scientific theory has to make assumptions, and those assumptions are the things you don't explain. It's just that simple. And if you get a new theory that explains those previous assumptions, then you got a theory with new assumptions. And so so scientific theories can never explain everything. There's no theory of everything. And that includes my theory. But what's interesting with the theory of consciousness that my team and I are developing it. Chetan Prakash, Manish Singh, Robert Prentner, Chris Fields, and many other brilliant colleagues. What's interesting is that theory itself sort of tells us that it's not complete. It tells us that, so because we have these basic ideas of entities called conscious agents, and when we have them interact, the interactions also satisfy the definition of a conscious agent. So interacting conscious agents are also themselves constitute new conscious agents. And that means that in some sense, all the agents that are interacting are one agent. But it turns out that as you keep doing this, you get into what's the notion of all the different levels of infinity. So you start to get, there's an infinite number of possible combinations of agents. And then when you look at the combinations, you start going at what's called the Cantor's hierarchy of infinities. So there's not just one infinity, there's an infinite number of infinities. And so our theory of consciousness really at every point says, well, when we've looked at this level of combinations, that's how far we've gotten up the Cantor's hierarchy, but we know that there's all the rest of the infinite, there's infinitely many levels of the Cantor's hierarchy ahead. So the way our theory is put out there, on the face of it, it tells you that this is not the final word, and it tells you why, because to get to the final one of consciousness, the deep, if you want to get a theory of the one, first there may not be one. It may be that in some sense, for principled reasons, this is open-ended. So it's not dual. There's no dualism. It's all consciousness. But it may not be that there's a single unity at the top. This is above my pay grade right now. This is pretty deep mathematics. But at least the theory is saying, look, right now we're at the level 0 and maybe the level 1, but there's an infinite number of levels. And so as we climb up the Cantor's hierarchy, we may find new and remarkable facts about consciousness at the deeper levels that may just blow our minds. But what's nice about it is the theory will always caution us, don't sit on your laurels. There's infinite work ahead. So this is job security for consciousness researchers.
Yeah, no, good way to put it. And I find it fascinating about what you had just mentioned about the morphology and DNA and the machine code aspect of it. When I was discussing this with Carl Friston specifically, I was trying to formulate, because I, of course, not being able to dispense with the same academic language, I tried to form analogies and then run them by my guests to see maybe if I'm on the right track. And I had kind of assembled in my mind something akin to that idea where the hardware and the machine, the ones and zeros, the bits and bytes of the transistors, activities, and I was thinking of that as like a motherboard kind of, and the containing within the motherboard being maybe the ultimate Markov blanket that contains transistors, and simply by being in an on or off state and being on a motherboard, they take on the role of a transistor. But by being a smaller part of a larger motherboard with a graphics processor, you have sound processor. It's almost like a little human entity, or not human, but non-conscious manner by which these smaller individual parts exist within a arena of consciousness. And simply by being in that arena, they have to adopt the parameters set by that Markov blanket. So if the motherboard has that kind of processor, these transistors have to work with, and by the nature of being on that motherboard, they adopt the principles of it. And so I was kind of trying to formulate, like, DNA is essentially the machine code, the nucleotides and the A, T, C, and G can take that code and form complex 3D proteins that eventually, branch out and differentiate into all the different cells. And that is interesting to me to think about how that would come about, and something about information at its core, like it went from there to that, thinking about information processing and information, like in black holes, looking at the physics of that, and now having seen that it's potentially hypothesized that things that go into black holes literally repopulate in 2D binary information that's equivalent to the surface area of the black hole, almost reduce matter down to a simple information at its core. And I was wondering, kind of, what's your thoughts on something like that? If there were to be a mechanism, could consciousness be almost equated potentially in the future to something like quantum information or quanta, or something like that?
Good question. So, because the paradigm that I'm proposing is a complete shift in the whole way we think about this thing. So, Carl Friston and the work on the Markov blankets and so forth is typically done within a physicalist framework. So they're taking space and time to be fundamental, and they're thinking about living systems as systems that maintain that manage to stay alive despite the second law of thermodynamics, that everything runs down, right? So they're maintaining a boundary between themselves and the world. They don't just dissolve into the world. They maintain this boundary, and so Friston's work is looking at those Markov blankets and maybe like talking about inferential processes inside the blanket that would somehow be maintaining that boundary. Now, that whole framework is assuming that there is a principal distinction between living systems and non-living systems. It's assuming that space and time is fundamental and that particles are fundamental. In other words, it's assuming things that we know are false, right? It has false assumptions at the get-go. Now, the abstract mathematics of Bayes nets and Markov blankets, work that Judea Pearl and many other people like Judea Pearl at UCLA and many other brilliant researchers, that mathematics is perfectly good mathematics, and that mathematics is not tied to space-time, right? That's completely general. But the way that Friston and his colleagues are using that mathematics is to assume that is modeling entities inside space-time. And they're assuming that there's a principal distinction between living and non-living things inside space-time. And as I've said before, that assumption is false. There's no print. So what we have instead are our interface gives us more information about the unity of entities, or consciousness is beyond space-time, or whatever's beyond space-time, and less. I mean, that's just the way interfaces work. They give you more information or less. When I see a rock, it doesn't mean I'm not interacting with something conscious. It just means that my interface has given up. It's not telling me much about that consciousness, right? So that's why you can see how profound the shift is, and why I think that all of my colleagues who are working on these problems need to really understand you have to let go of space-time. And when you do let go of space-time completely, it's not fundamental. Everything you're doing, every aspect of it is going to be radically different. There's nothing left, essentially, of the old approach. Reductionism is gone. The distinction between living and non-living is gone. The distinction between conscious and unconscious is gone. All those distinctions are gone. And the idea that you can build up more complex systems from simple systems is, again, an artifact of our interface, right? Right now, I see a bunch of pixels that are your face. Well, yeah, that's great, but it's property of the interface. It's not something deep about those pixels, and they don't create a face. They're just pixels, and so you can see now the way the Markov blanket is often used. Well, let me say one thing that I like about the Markov blanket idea. The Markov blanket says that it has an organism on the inside, and then there's the world outside the blanket, right? Yeah. And then there's the blanket itself. And the key fact is that the state of the environment outside the organism is independent of the state of the organism inside the blanket, given once you condition on the state of the blanket. In other words, the blanket itself has all the information that you could ever have about the external environment. And when there is a vast environment outside the blanket, that data compression is enormous, right? In other words, the information that the blanket has about objective reality is at best a massive projection. And there's no reason to think that we're seeing the truth. So I put this, the Markov blanket model once again tells us that our perceptions must be just a user interface. They cannot be the fundamental reality. They're a massive projection, and what evolutionary theory tells us is that projection is not structure preserving, except for one structure called a measurable structure for probabilities. But other than that, so the Markov blanket theory doesn't tell us that. It doesn't tell us that the projection from the entire Bayes net down to the blanket couldn't be homomorphisms with certain structure. I don't think that there's anything theory that I know of right now that says that it couldn't be a homomorphism and therefore give us information about the external world. But the evolutionary theory clearly tells us that the only structure that is guaranteed to be preserved is the measurable structure, and all other structures are not guaranteed. In fact, probability is 0 that they're preserved. So,
and that makes sense. It's you have to get rid of the notion of space-time being a prerequisite, and from there you must discard several presuppositions that are commonly held, and of course nothing wrong with that. And in fact, that's increasingly where, if you look into consciousness, it seems like, and you pry into it further and further, you eventually end up at a position where you almost have to have this intuitively inverting idea come to the forefront, and it seems inevitable. And like you had just mentioned, having like a user interface. Bernardo Kastrov is a philosopher I listened to who proposed analytic idealism, and I found that school of thought to be pretty unique, and also it provided a body of language by which to dispense with this a little bit better for me whenever I came across it, because he had that consciousness first ontology, that he was presenting with that. And there's not a whole lot of those ontologies out there that get much credence, like you'd said, because it's kind of on the cutting edge of this idea. But he proposes something similar to what you said, like the idea that maybe we're in the cockpit of an airplane, and evolution has given us instrument clusters by which to navigate this reality, and therefore what we're actually perceiving and seeing is simply what evolution has preferred us to see and believe and to perceive in order to more basically nurture survival, as opposed to seeing the reality for what it is. And that, in a sense, would imply mind preceding matter significantly, I would think. And so I think, like kind of like what you said, evolution hasn't naturally selected us to perceive the truth.
Right. So Bernardo Kastrop and I are good friends, and he runs he's the director of the Essentia Foundation, which is studying. I'm on the board. I'm somehow a member of that. I forgot what exactly my function there is, but yeah, no, I've known Bernardo for many years. He's brilliant. We're very much on the same page in terms of consciousness being fundamental. He is a philosopher. He also has got some mathematical chops. He's pretty sharp mathematically. So I've asked him, pleaded with him to help us. We're working on a mathematical model of consciousness, and it's very, very similar in spirit to what he's doing philosophically in terms of his analytic idealism. And so I'd love to have Bernardo working with us, even more integral part of our team in terms of actually working on mathematical models of it. I can say one place where we'll have to have conversations going forward, because we seem to disagree on one point. So it'll be fun. I mean, it's always fun to disagree with someone who's brilliant, because you're going to learn something. So I'm looking forward to learning from Bernardo as we discussed it. But he's suggested to me that he thinks there might be trouble with our theory of conscious agents, because our conscious agents are not inside space-time. So there's no ambient space for them. They're prior to space-time. And for him, there's a philosophical question about whether it makes sense to try to individuate conscious agents when there's no ambient space to individuate them within. And so that's going to be an interesting discussion. I see no problem with it. I can individuate the sine function from the cosine function from the tangent function, even though I'm not thinking about these functions as having to be inside some kind of space-time. They're different functions, even though they're not inside space-time. So I don't see a principal problem there, but I'm sure Bernardo has some really interesting ideas. They'll have to, I just haven't had a chance to pursue them with him. But yeah, so this is good. I mean, we're on the same page. I would really welcome him to work with us on the mathematics. But where we disagree now is really going to be fun, because I'm going to learn something from Bernardo, or and that'll be good. So it's all good.
Yeah, no, absolutely. That's great. I'm glad to hear that. I look forward to learning more about it. And I think y'all's both the take you have and him, they synergize together well. And it's been very neat discovering both of you guys at the same time to try to, because you had mentioned Annika Harris in a couple interviews you had in the past, and I really found a lot of insights from her book that she wrote, kind of promoting panpsychism, but it was an inevitability in her mind, that something had to be fundamental. And panpsychism in itself is like we had said earlier, it's an interesting conduit to idealism to me, or to not idealism, but as you call it, conscious realism or analytic idealism. Those philosophies, inevitably, it seems like panpsychism provides that conduit to get there. If you can move in phases upwards. And I know your like conscious realism, as you propose, it kind of doesn't involve a self or involve an agent in the same perspective manner that most people, when they're viewing consciousness, they start with phenomenal consciousness being integral to the use of self and language. So, right. That's a hard one for me to. I totally like the work. I mean, I think it's some of the most unique out there to go at consciousness like this. But it's difficult intuitively to get in the space to start feeling it out. And so I was going to ask you, when we remove the notion of self as an integral component from it, we're looking at consciousness as something completely different, defining it differently. So have you encountered this problem of the self and agency, and are you trying in a way to integrate that into this, or leave that to the side kind of as a focal point?
Right. So Annika is a brilliant thinker and a wonderful writer, and she and I are good friends as well. We before the pandemic, we were meeting quite frequently for lunch. We had a sushi bar we like to meet at, and we would talk panpsychism and conscious realism and so forth. It was a lot of fun, and she. I agree with her. She thinks that a self is not fundamental. And even though my theory is called conscious agents, and when the term agent seems to conjure up the notion of a self and so forth, but it's really just a technical term. So so the theory of conscious agents it does not assume that there's a self up front. It's not one of the fundamental aspects of it. And so in that sense, it doesn't assume a self with free will. If it doesn't assume a self, then it doesn't assume a self that has free will either. The idea, and the reason why, is when you start to boot up a theory of consciousness, or any theory that you're trying to, you want to have as few assumptions as possible. And the reason for that is not laziness, quite the opposite. Everything that you assume in a theory is something you're not explaining. It's a miracle for that theory. So you want as few miracles as possible. So when I was working with my colleagues trying to figure out, okay, we want to boot up a theory of consciousness on its own terms, not as consciousness emerged from this physical system or that functional thing or what. I want consciousness qua consciousness, period. Forget space-time altogether. Don't even think in that framework. Consciousness itself. What would be the minimal theory? So I'll just say, notice how different that is. Integrated information theory is really talking about the properties of physical systems would have to the right complexity of causal interactions to give rise to consciousness. I'm saying we don't think about it that way. That's still within this space-time reductionist framework or some kind of abstract reductionist framework. And you're trying to build up from the functional properties of something. I'm saying consciousness itself is the entity. What is the minimal structure we need to posit for this entity? Not the minimal structure of something that might give rise to consciousness. What is the structure of consciousness itself? I'm sort of harping on this because it's so counter to the way 99.9% of people are thinking about it that I really have to be very, very clear that this is a clean division. We're not starting with something and trying to boot up consciousness. It's consciousness on its own. So I proposed only two things. There are experiences, conscious experiences. Now there's an interesting question about what's the minimal number of conscious experiences we might need to propose, but I'm just proposing that there is a category of conscious experiences. How big that category is I'm leaving open right now. Because maybe we get away with two. Maybe all we need is two experiences, and we, from combinatorics, can get everything. I don't know. We'll have to see. But there are experiences, and second, that those experiences can affect other experiences, the probabilities of other experiences. And we capture this in a mathematical formalism that we call conscious agents. But that's, and the formalism just, it captures it. So I gave you the intuition. The mathematics is something called Markovian kernels, which involve probability spaces in the domain and range of the Markovian kernels. So those are the two things, conceptually, conscious experiences and probabilistic changes of conscious experiences based on the prior conscious experiences. Now to get to your question in a little bit more detail. It's trivial to prove that networks of conscious agents, which are modeled by these Markovian kernels, are computationally universal. That means that anything that you could compute with a neural network, you can compute with a conscious agent network. It's completely universal. In fact, it's beyond computational because the Markovian kernels are not restricted to computations. They can be defined over non-computable sets. So networks of conscious agents can compute anything that a supercomputer can compute, anything that a Turing machine, a universal Turing machine can compute, but also they're not restricted to that kind of computation. So that means that even though I've not assumed learning, memory, problem solving, intelligence, all these, free will, I have all the tools that I need to build conscious agent networks which instantiate them. We have a paper, Chris Fields is first author on a paper where we do several of these things. We actually build conscious agent networks which are doing some of these things. So notice what we're doing. We're saying we're not assuming the notion of a self in our definition of consciousness. However, we can build networks of conscious agents that implement a model of a self if you want. You can do that. But the self itself is not fundamental. And that's what so we don't have any notion of learning or memory or intelligence or problem solving. But we can build up networks of agents which do any kind of learning, memory, problem solving that you want. So that's what you really want from a scientific theory. You don't want all the miracles. Everything's a miracle and there's nothing to explain here. I'm done. No. All the work is ahead. All I have to work with is their conscious experiences and probabilistic relationships among them. I've got to build everything else out of that. So the work is all on us. So that's what you want in a scientific theory. And so I'm not saying that we can't build selves. Surely we can build a self, but the self isn't a fundamental property of the conscious agents. And so in some sense, it's that's a bit sobering. I sort of like myself. We're all addicted. We sort of, there's something, but we in some sense know that a lot of the stuff that we take as important to it, we're going to walk away from it all. We're all going to die. And it's not clear what of the story. I mean, myself is in some sense a story. I was born in such and such a place at such and such a date. My parents were such and such. I did this with my life. These are all stories. In some sense, if you just sat here, if you could do something right now, like, just give me a little a zap where for the next 10 minutes, I didn't know that story. It was just gone. I didn't know my name. I couldn't tell you, but I'm still alert. I'm still here sitting consciously. In some sense, the real me, the real me is not affected at all. I lost that story, but the real me is perfectly good. I can't tell you that story right now. And maybe that's what a self is. It's just a story that we're sort of attached to, and we cling to it. But maybe when we die, that's the story we let go of, and nothing is really lost.
That's a unique way of framing it. I think that there's something critical about the autobiographical narrative that we construct, and it's psychologically, you know, I think it is understood, like the ego and things like that are more of a facade or a construction that's, you know, created to exist. And to use language adequately, you have to presuppose a self generally, because language is dualistic. So when you communicate, you have to say I, me. And so by the nature of language, you're kind of forced into a paradigm of dualistic perception of the world, mind and matter being separate and me being unique and other being not. And so I think the phenomenology of consciousness seems, at least intuitively to me, to hinge on this advent of language, and not hinge on it like it's coming from it or that it presupposes it, but that language in itself is what produces the ability to articulate phenomenology and phenomenal consciousness. Because really, I mean, you think of an animal, I mean, you suppose that an animal that's nonverbal, a deer or whatever, runs away from predators and acts in favor of its survival, and it would have to suppose it knows it has an organism separate from other, because it knows when a predator's here and it's here. So the mobility features of an animal, it has a nervous system. So you would suppose it has the idea of its unique Markov blanket separating itself from its predator, but it can't communicate me, I, of course, by language. And then humans kind of separate themselves dramatically in the evolution of that just by the nature of language. And then with language gives you the ability to start seeing and verbalizing subject as other and self. And that's why it seems to me like the uniqueness of humans as a specific species with a nervous system is that meta ability, that meta conscious level, where a lot of times, like when I was speaking with another neuroscientist, he was more of a functionalist. And I think he hinged that perspective primarily on that uniqueness of the meta ability of us to think about thinking. And he's something about that so unique to humans. It's so hard to dispense with conscious. You want to make it unique and human and centered in the brain, because we seem to be the only species that can do some of those things.
Well, so you're right that language itself sort of induces us to use subject and object and have a dualism that's right there, and that's perhaps an artifact. So if, for example, in this theory of consciousness, if in some sense all conscious agents are, in some sense, they have the same structure, and then when conscious agents interact, they're not separate conscious, they are a single conscious. In some sense, we're all part of one big conscious agent, even if it's put it this way, it may be what some spiritual traditions call non-dual, but it may not be unified, may not be one. There may not be one conscious agent for technical reasons. So, this Cantor hierarchy, maybe in some sense you never reach the end. There's never any final unification. So it's always approaching but never reaching a unification into one. But it's not dual in the sense that it's consciousness all the way down. So then the reality of consciousness in this model is infinitely complex, and it's not just a countable infinity. It's uncountable, and then all these other levels of it. In other words, it's all of our language then is going to be woefully inadequate, because it's an infinite to one projection from the language from the reality down into language. We see this in Gödel's incompleteness theorem, that Gödel says, if you have any finite language system, set of axioms and production rules that's at least sophisticated enough that it could do arithmetic, then there'll always be true statements that can't be derived from within that system. And that means that any language system that we have, or any like computational system that we have, is inadequate. There will always be countless truths that are beyond any language description that we can give, or any scientific mathematical theory. So in other words, all of our theories will always be just scratching the surface. And this is something that I think Newton pointed to later in his life, where talking about his life as a scientist and perhaps also as a theologian. He said that he felt like he was a boy on the seashore finding a particularly interesting shell or a pebble, but the vast ocean of unexplored reality lay all before him, and then he was just playing on the seashore with it. Even though he was perhaps the smartest human in recorded history, I think that's probably widely accepted. There's probably no one smarter than Newton, and yet he felt like he was just and that's my attitude as well. That our theories, no matter how advanced they, and even a billion years from now, if we're still doing this stuff and getting deeper theories, will have only scratched the surface of reality that transcends it, and it may be a non-dual reality in the technical sense that I talked about. So where all these agents are constantly unifying into one agent, but that's never done because you have to go all the way up the Cantor hierarchy and the possibilities of unification. And I just don't know if you ever reach that limit. So that's for me. I just put out what for me is an open technical question that is raised by our framework about consciousness. But I don't know the answer. Maybe some mathematician. I'd love to talk with a mathematician about that. But notice the change. Now that there's a mathematical theory of consciousness, we start getting really technical questions about consciousness that get raised, and now you want theorems and proofs and so forth. So this really changes the game from bull sessions over beer on Friday night about life and consciousness to, wow, we have technical questions here. Again, I'm not saying my theory is right, but at some point maybe the theory will be sophisticated enough that I can show that it's wrong. And that's what you really want, is to get your theories far enough along that you now know that they're wrong, or if not wrong, limited, that there's more. So but your point about the language leading to this duality, and that it perhaps being an artifact, I agree completely, and it's a pointer to something very much deeper that's going on here. Yeah, absolutely.
Yeah, awesome. Yeah, that it is intriguing, and it seems to me too, like I was kind of briefly touching on earlier about the idea of information, and how, and something seems to me intuitive, just that there is this monistic, non-dual consciousness pervades everything as a fundamental element. And I think that physics too, I think by showing, I guess I wanted to ask your opinion. I know it's maybe out of your element a little, and I don't really know much about it, but it seems like there's a link that can be drawn to further this idea of analytical idealism, conscious realism, these perspectives that prioritize mind. It seems like it does a lot of credence to it with physics, if the black hole's idea of matter being reconfigured into information, and not simply lost like originally thought. And to me, then if that's the case, if three-dimensional matter can fall into a black hole and it's repopulated in 2D information, if information could be equated at some level, at a quantum level or something of that nature, to the very substance of consciousness, essentially, maybe, and we as agents exist within that informational field, and since we have conscious experience, like one of the assumptions you're making, like you had said, you're presupposing an assumption that there's conscious experiences and that these experiences initiate a causal chain. And those assumptions, I presume that's kind of the two you're making. And like you said, you want to limit the miracles of these situations to the least of miracles. We have senses that have to perceive information. So I was kind of thinking consciousness operates as the ultimate operating system, or something by which an agent can decipher. If all of this matter is typically information, then the processing system must have the right operating system to disassemble that information and then bind the sensory data back together into a formidable perspective on how to navigate around. And so I'm thinking, I wanted to ask you, I mean, could it be potentially that that physics is doing a favor in that regard, maybe, right, in quantum information, and how that could be the fundamental Markov blanket? I keep wanting to go back to that, or the fundamental sphere of what consciousness might be substance-wise.
Well, so information theory is typically discrete. I think there might be notions of continuous information, but typically it's discrete, and certainly as it's being used by the physicists, they're talking about discrete quantum information theory. And it is true that the amount of information that you can stick into a region of space depends only on the surface area of that region of space, not on the volume of the space. And that's stunning to most people's intuitions. I'm sure that people, just like me saying that, don't understand why. So I'll give you a concrete example. Suppose you're a computer engineer and your job is to come up with a mass storage device for information for your computer. And you're given two options. You can have one sphere, and the volume of that sphere, you can use that. Or I can give you 6 smaller spheres that pack inside that bigger sphere. But of course, there's all sorts of gaps between them, right? There's the volume of these 6 smaller spheres is less than the volume of the big sphere that they're all packed in. And I say, which of these two? So you can either put all of your memory in this one big sphere, or you can put it in these 6 smaller spheres. Which would you choose? Well, I always would go, I'd put it in the big sphere. Well, it turns out, if you do the math, the surface area of the big sphere is less than the surface area of the 6 smaller spheres that are packed inside of it. So in fact, you can put less information into the bigger sphere than into the smaller 6 spheres. Okay, now, if your brain is catching fire, that was my intent. This is how strange this is. So once you really understand what the physicists are saying, the amount of information depends on the surface area, not on the volume. And that means if I take a big sphere and have 6 smaller spheres that are packed inside it, I can put more information in those 6 smaller spheres that are packed inside the big sphere than I can inside the big sphere. Okay, that's what it means. So I can see that your brain is catching on fire, and that's good. Everybody's brain catches on fire.
Yeah.
So what's going on here? What we're really seeing is the evidence that space-time is just a data compression scheme. It's just a data storage. It's not a fundamental reality. It's a data structure. And that data structure has certain limits. They're called, it's the notion of space and time have no operational meaning. There is no operational sense that can be made of those when you go to 10 to the minus 33 centimeters or smaller, or 10 to the minus 43 seconds or shorter durations. So it's not that there are pixels of space and time at that Planck scale. It's that space and time itself ceases to have any coherent operational meaning. So what we're seeing, when we look at the quantum information theory and we look at black holes and so forth, what we're seeing is the very aspects of space and time that the Nima Arkani Hamed and others have been using to say space-time is doomed. It's not fundamental. So that's the big contribution. I mean, quantum information theory has got contributions at many, many levels, and it's going to be a very powerful technology, and it's very, very important. But one contribution is to tell us very, very clearly that space-time is doomed, that space-time cannot be fundamental reality. And so what we're going to have to do is understand really what we're dealing with black holes and this the principle that the information is only, it's called the holographic principle. The information is only proportional to the surface area. To really understand that deeply, we can't do it from within the current space-time physicalist framework. And I'm not sure exactly how we're going to finally do it. Here's the way I'm trying to understand it right now, is I'm starting with the theory of conscious agents, looking at its long-term behavior, projecting that long-term behavior onto the Birkhoff polytope, using that to go to the amplituhedron, and then going from there, the physicists take us into space-time, and then asking, okay, so space-time now is some data structure, and we now know how this data structure is produced by projection. Now we need to study more about this data structure. So this data structure right now is giving me the space-time data structure that I'm using is giving me some information about your conscious experiences and what you're thinking. So it's giving me a little bit of insight into Ethan, but right now it's not giving me any insight, for example, into what Annika Harris is thinking, because I'm not interacting with her, with my interface. So how is it that what is the structure of this interface that's giving me right now access to certain consciousnesses like Ethan's, but not to others, like, the president of the United States I'm not getting access to his consciousness right now. So we have to unpack. We have a lot of work to do to unpack this data structure and how it works. Once we understand that, then we'll begin to understand what black holes are telling us about the limits of this data structure and so forth. So you can see my answer to your question is very, very different from where most people are thinking. Quantum theory is fundamental. Quantum information is fundamental. And we're going to try to boot it up from that. I'm saying I agree with Nivar Haqqani-Ahmed and his collaborators when they say quantum theory itself is going to arise with space-time. The two are going to arise together, as he says, joined at the hip. So you can have space-time and quantum theory together, joined at the hip, arising from some deeper structure. So that means quantum information theory is not most fundamental, and that's surprising. So Chris Fuchs, for example, who's a brilliant physicist, and I have the privilege of knowing him and having, we were at a conference together just a couple of weeks ago. He's starting with quantum information, which I think is more fundamental in some sense than what we might call quantum physics. It's the information theoretic core of it. But what Nima is saying is that there's an even deeper level, quantum information. There is a place, a deeper theory in which there are no Hilbert spaces. You need Hilbert spaces for quantum information theory. And we're going beyond space-time, we're going beyond Hilbert spaces, we're going to something deeper where there are no obvious Hilbert spaces. But with quantum theory, my guess is that the properties of quantum theory that are really interesting, like entanglement and superposition,
yep,
these are simply the result. They're telling us that what we're seeing is a projection. We're not seeing the truth. And when you can't see all of the truth, when you're looking at a projection of the world instead of the actual truth of the world, you will get entanglement and superposition as just indications that they're telling you, no, you're not seeing the whole thing. What you're seeing, everything you see, there's many things that projected to it. So quantum theory is a way of recognizing that what I see in space and time is a projection of something that's perhaps infinitely more complicated than space and time. And so as a result, I can't just keep track of things in space and time. I have to do something that makes me look like I'm taking track of multiverses out there, right? So that's one way that people try to interpret what the mathematics of quantum theory is, to say there's multiverses out there. Well, yeah, really what's going on there is not multiverses of like space-time, but it's just this, there's a realm beyond space-time that's infinitely complicated, and space-time is this infinite to one projection, and that's why we get entanglement and superposition. So from that point of view, quantum theory, a lot of theorists, I think, right now are thinking quantum theory is the fundamental. And no, I think it's tied to the interface. I think the properties of quantum theory that seem so counterintuitive are tied to just the fact that interfaces lose information. and so once we go to this deeper theory, we will see how quantum theory emerges as just an artifact of projecting onto an interface.
No, wow, yeah, no, that's well said. That's a perspective of looking at consciousness that's super intriguing because it's so unique, and it's so needed. I think because in my mind I'm processing what you're saying, and of course with automaticity, I'm comparing that relative to what I already believed or thought, just because I'm observing myself and this is an interesting framework to shift into, to start looking at consciousness through this lens. And so it's and having listened to Kastroff and your takes and lately and stuff, it's helping me slowly shift that intuition to where it needs to be, to start synergizing with this thought, because I see it feeling like intuitively, it has a lot of core truth to it. And it seems like, ultimately we always seem to compare something relative to something else, whether it's perception of an object, we perceive good, we compare it to bad, or it seems like to be in existence and describe an object, it requires this relativistic framework. And that to me almost could be extrapolated potentially further to any sense of being. You would want to ultimately compare relative to something ultimate, something further beyond it in a way. Like there's this like deep yearning, I guess people always do want to know or be closer to the truth, but the truth is always a little bit outside of what we're actually experiencing. And so this idea of projection that you mentioned, I find a really cool phenomena to look into. Just even like consciousness, an avenue to look at consciousness was through the science of visual perception, and how humans, are able to distinguish like a white picture on a white background, but a robot can't. I know it's a simple thing, but to me, it's an interesting phenomenon when looking at consciousness. And visual perception is essentially taking, photons of light, and there's that effect. I forget the name, but the fermion transformation, I believe, where the retina basically takes and assembles a 3D reality from light. And so it always makes me wonder. I mean, the eye is a surface of the eye is producing this reality through visual perception. And a robot, you can't even get a robot, the most advanced, some of them, to tell a white picture. They have this inability to frame anything like so it's like, seems to me like visual perception too, as just a phenomena of how we assemble and project our reality is something that could lead to insights into this.
Well, I couldn't agree more. In fact, that's been my background. So my dissertation for my PhD was on visual perception, and I have a book that called Visual Intelligence: How We Create What We See, and it's for a broad audience. It's not for a mathematically technical audience. It's for a broad audience, and it goes exactly into what you're talking about: how we start with photons captured at the photoreceptors of the eye, and how we create shapes and colors and motion and so forth. So I go through and give more than 30 different principles that visual neuroscientists have discovered about how that process. And so my work on consciousness has been, of course, very much informed by that understanding. And my work on the idea of user interfaces has been informed by my work on the cognitive neuroscience of visual perception. But it was also informed by, way back in 1976, through and a few years after that as well, I worked at Hughes Aircraft Company as a member of the technical staff there. And one of the things I did was we delivered a flight simulator. In 1978, we delivered a flight simulator to Wright-Patterson Air Force Base called the Digital Avionics Information System, DACE. And it was, I and a few other programmers did this in essentially machine code. All the ones and zeros. We did an entire flight simulator in 64K. 64K. Wow.
That's incredible.
So you basically, so back in 1976 through 1978, I was working on building user interfaces where I was actually using the ones and zeros to build them. So in some sense, my background really forced me to understand user interfaces and to go through the hard nuts and bolts of how you build them and how you could build a flight simulator in only 64K. So, and then I went on and did a PhD after that at MIT, where I then studied visual perception. And so I think that it was a unique background that helped me get the perspective that I needed to go after this user interface, because I spent my time, earning my living building a user interface and seeing how it worked, and then working for my PhD on visual perception. How does that work? And so I just was lucky that I had this kind of background that could then give me this particular set of tools. But something else you said earlier on in this question is important too, that it is a shock to the system to think in this new way, right? It's very much a shock, and you really have to go in with both feet or not at all, right? So think about the transition from Newton to Einstein. The Newtonian might say, well, look, but but I don't understand. If I do this over here and I do something over there at the same time, and then Einstein comes back and says, you have to let go of the notion of at the same time. The notion of simultaneity, that's then the Newtonian is flummoxed, right? And then he's as I move things and I can keep accelerating, I just keep accelerating. Newton said, no, its mass is increasing. What? The mass? everything changes. All of your so you can't just sort of like go from Newton to Einstein unless you go in all the way, and you have to go with both feet, and you have to say, okay, the speed of light is universal in all reference frames. Period. It's universal in all reference frames. What does that mean? And then your whole world changes in ways that you never expected. You mean as I speed up with respect to you, I have more weight, my clock slows down, I can't talk about simultaneity. Everything that my whole Newtonian world is just, it's shot to pieces. That's what you have to do here when you let go of space-time. And again, it's not because Hoffman says to let go of space-time, it's because quantum field theory and gravity say to let go of space-time, and evolution says to let go of space-time. So forget Hoffman. It's our best scientific theory to say it's over for space-time. When you let go of space-time, you have to jump in with both feet. You can't, you have to jump in with both feet, and the way you jump in is to say, here's my theory of what's beyond space-time. Of course, I'm probably wrong. Who knows what the truth is? But I've got to jump in with both feet and come up with something that can project to space-time. That's how I'm going to get my connection to experiments. I have to project my theory into space-time where I can do my experiments, and I better, I can test it. But get ready for Alice in Wonderland, just like Einstein is Alice in Wonderland for anybody who's Newtonian. Letting go of Einstein, letting go of space-time was a bigger leap, for Alice than the leap from Newton to Einstein. This, letting go of space-time altogether is a leap too far for most people in my generation. But I think the younger generation that spend time in the metaverse and have spent a lot of their life in the metaverse, and it will not be a big leap to think, well, when I take off my headset, maybe I'm still inside a headset. Maybe this is still a headset. It's not going to be a big leap. And I think so they'll be ready to make the leap more than the rest of us.
Absolutely. No, I think that's a good, practical, pragmatic way to look at it. The headset idea with virtual reality and the metaverse, I think that encapsulates it pretty well. And it doesn't, and like you said, the eyes act as a goggles almost. I mean, it's quite an incredibly inexplicable phenomenon what visual perception is, and just looking into it, I mean, it's a bewildering inquiry to make, and to hear, your fascination with that and your work in that arena is so fascinating, just because it shows me that there's so much more to know about visual perception, that it's obviously a strikingly brilliant phenomena that it's always like, every time I think about it, I learn something new about visual perception. I'm like, that is just outrageous. That's just amazing what it's really doing. And then you wonder, what that means for our reality, which of course is the reality, what we're seeing, a simulated version of itself. And of course, that's a good question. And there's something about too, like contingency. I don't talk about theology much, but philosopher like Thomas Aquinas in the Middle Ages based his proofs for a creator. I mean, and there were deep philosophical proofs with the best metaphysics you could dispense with, like Aristotelianism at that time. He focused on that platform, and he used one of his arguments for a creator, this idea of contingency, and basically every finite reality or every finitude that exists depends ultimately upon something infinite or something outside of time. That was his presupposition that he was making through this theorem, or this philosophical proof, was that when the sun comes up and the moon goes down, and this continuum of this has to hinge on something that's ineffable and outside of itself. Like almost all finite existence depends inherently upon something further than itself or beyond itself. And the reason I'm bringing that in is simply because one of the main things I was trying to do with having these discourses was produce conversations that also increase meaning for people, to when they look at consciousness, it doesn't devolve to a nihilistic perspective. Because I see, at least myself, when I got started looking into this, it was all this pressure on dissolution of the self, dissolution of ego, dispensing with illusory free will, and all of that may be fine and good, but sometimes it's nice to ground the study of consciousness in meaning, so that that's not lost for people in the process. And so that's why I tried to link it back to that. Even if it was a simulated reality, even if our perceptions were, not as what they seem, that gives more inherent meaning to this purpose. I mean, now you have more to figure out. It's almost like the contemplation of this becomes the integral part of the meaning. So I think that's cool.
Right. I agree completely with your attitude here. And when we take consciousness to be fundamental, we have a mathematical model of it. The natural question comes up: what is consciousness doing, and why? Right? And any theory that's going to say consciousness is fundamental better try to address that question. It certainly can't ignore that question. It could say, above my pay grade for now. You could say that, but you can't ignore the question. You can't say that it's not a legitimate question. And I don't know the answer to the question, what is consciousness doing or why? The only idea that I've run across that seems deep enough to be worth considering so far, and I'm not saying it's the right answer and the only answer, or the only answer, I'm just saying it's the only one that Hoffman's small brain has come across, that the Hoffman small brain thinks is relevant. And that's Gödel's incompleteness theorem. And Gödel's incompleteness theorem effectively, or theorems, I guess there's two of them, but it tells us that there's no end to the possibilities of mathematical structure. The mathematical structure is inexhaustible. And if consciousness is fundamental and consciousness is all there is, then mathematical structure could only be about consciousness and its possibilities, its varieties, its possible experiences, and so forth. And what this would entail then is that there is no end to the exploration of the possibilities of consciousness. And the only thing around to do that exploration is consciousness itself. So this suggests that consciousness, one way of thinking about this then is that what is consciousness up to and why? Consciousness is up to knowing itself, is up to exploring all of its infinite possibilities. And this is continuing right now as we talk and so forth. And it continues because in principle, it's endless. There is no end to it. And what this, under this point of view, what's happening is that consciousness is taking on various kinds of, it's plunging itself into different virtual worlds to say, okay, well, let me put on the non-Hoffman avatar. So I'm putting on this, and I'll have myself born in some hospital somewhere in some year, and I'll have put myself in certain parents and brothers and sisters, and I'm going to explore what it means to be consciousness with this particular headset and this particular avatar. And consciousness also puts on an Ethan Ivy avatar and headset and so forth, or a Bill Gates avatar, or whoever it might be. So consciousness is putting on and puts on other avatars that we do not really see too well through our own avatar, right? So when we look at monkeys, we think that we're seeing lesser beings. When we look at ants, we think that we're seeing lesser beings, and we feel superior. In fact, we're interacting with exactly the same consciousness that we are, but what happens is consciousness is actually apparently letting itself so thoroughly explore that it's willing to lose itself. It loses its own identity. It says, I'm not just going to play explore. I'm going to plunge in with both feet. I'm going into this Hoffman avatar with both feet. I'm going to wear diapers, and I'm going to have poop on my butt. My mom's going to wipe the poop, and I'm going to go through this whole thing, and I'm going to go through it. I'm going to die. I'm going to go through this whole thing, and I'm not going to even know who I am. I'm going to let myself so I'm so immersed in this headset, and then maybe I'll wake myself up at some point. Who knows? Or maybe I'll in some avatars I'll die without not ever knowing, and it's only in the moment of death when I take off the headset that I go, whoa, that's what just happened. So that may be so talk about meaning to life. Then what we're doing is not divorced from the main purpose of the universe. You are the universe itself, fulfilling its purpose by exploring its possibilities. And so that changes the whole perspective Well, once again, you have to jump in with both feet or don't do it at all. Right? When you so I've learned to do that. Just jump in with both feet. Right? It's like with the germ theory of disease. Before we had the germ theory of disease, we didn't know why people got sick. But there are little animals crawling around that you can't see. Give me a break. There's little animals all over, and that's what's causing. But you have to just like plunge in with both feet. Take that theory seriously, and that's how you learn to deal with disease. And so with this, the same thing. You have to just plunge in with both feet and start to explore a space outside of space and time.
Yeah, absolutely. No, I think that's an illustrative way of describing it. And I think that and like you said, it provides meaning by inherently being in existence. It's a well-examined life becomes meaningful. And I think maybe that's why the root of the word philosophy is the love of wisdom. Is people philosophize. People like Socrates and Aristotle spent their whole life philosophizing. Obviously, it brought them happiness, peace, something about the contemplation of knowing yourself and knowing and examining your life in respect to the world is inherently a meaningful pursuit. And the function of consciousness, potentially, that's a beautiful function. If you think about it, it provides that intrinsic drive to pursue an avenue of creativity or an avenue of innovation. And it gives you that logos by which to place as your hierarchy of values and actualize the potential. That seems like consciousness works towards actualizing potential. I mean, that's like how ideas always work. Is somebody has an idea to build an engine, and then all of a sudden he's doing it. Then somebody else has an idea. They put an engine on something. Now all of a sudden it's a plane. You know, it just seems like ideas grab on to consciousness too, and they come into existence. And ideas operate in this consciousness. And I think about it sometimes. This idea of just going to chemistry is intriguing when you think about it from the perspective of conscious realism. Is the intuitive, natural, really unexplained phenomena of like covalent bonding and things like that, to where you have complexity even at the molecular level trending towards a more complex, even if it's not alive, as we were trying to draw a line between alive and not. But like you said, there may not be as tough a dividing line between the forces of selection that involve the covalent bonding and sharing, or then you have ionic bonds where there's a literal like they're stealing electrons from each other and becoming infused to each other. And then to escalate that to nuclear fusion, to where you have two atoms becoming one in the nucleus. These processes are entropy defying. And I know you have some perspective on entropy with the Markovian dynamics, where entropy is kind of at zero. If I kind of heard you explain that a little bit, I'm probably misunderstanding it, but entropy defying appearances such as nuclear fusion, it seems like complexity and the forces of selection that we presume to be behind biological evolution are at work molecularly, chemically, and in all facets. So it kind of helps me see that, consciousness being fundamental isn't too of a crazy idea. If you look at how chemistry works, it seems like even molecules are trending towards some selective pressure.
Right. So, yeah, consciousness being fundamental, and the idea that maybe what consciousness is up to is exploring all of its potentials, and just the fun of getting lost in the exploration. And so some of us are artists, and we explore. So that's consciousness exploring its potential with a life of painting or drawing or videography or something like that, or dance or music or some science or building companies or doing whatever, being a surfer. So there's consciousness is just out there, and it's all good. It's all consciousness. Even exploring what it means to be a gangster or a criminal, or it's exploring all of the and eventually then you take off the headset and shake hands and move on, right? So it's sort of like it's quite interesting that way. But one objection that one might have, let me say a couple objections that one might have to what I'm saying on all of this stuff. So, and these are objections that have been raised. One is that what I'm saying is self-refuting. So I've been saying, on the one hand, that evolution with natural selection tells us that we don't see the truth, right? So space and time isn't fundamental. It's not the truth. It's just a user interface. And then on the other hand, I'm saying that my perception of your face is giving me insight into your consciousness. You know, I'm getting truths about your mood and so forth. So what gives? I mean, the philosopher Philip Goff, for example, who's a panpsychist, says that he thinks that's a reductio ad absurdum of my point of view. It's self-contradictory, and so to understand it, you have to understand two steps that are going on here. This is the way we always move when we go from one scientific theory to the next. So you have a scientific theory, in this case, evolution by natural selection, which is a physicalist. We've thought of it as a physicalist theory, but it tells us that space and time is not fundamental, and effectively that what you're seeing is a user interface. So it tells you that. It does not tell you what's beyond. It doesn't say, you know, it's an interface to, and then it tells you what it is. It just says it's an interface to some reality. I'm not in a position to tell you what that reality is. Yeah. So now we have to make a leap. So I used evolution by natural selection. It's a theorem. You don't see the truth from within the context of that theory. Okay, you're seeing an interface. Now, step two, I'm going to make a leap. I'm going to propose a theory beyond space and time because evolution said I needed to do that. It didn't tell me what theory to propose, so I could be wrong about my particular theory, but I'm not wrong to try to propose a new theory, at least not according to evolution. I'm not wrong. Yeah. So I'm proposing this new theory that in which consciousness is fundamental, and that my interface is an interface to consciousness. Yeah. And because it's an interface to consciousness, I can expect them to have some insights about consciousness through the interface. So that's why I'm not shooting myself in the foot logically by doing this, right? This is how you build. So this is, it's important for people to realize this is not a reductio ad absurdum of the point of the whole approach. It's first, our evolution tells us you're not seeing the truth, whatever the truth might be. Okay. Now we take a new, deeper theory. So according to this theory, what am I seeing? Well, you're seeing consciousness according to this deeper theory. Now, what I have to do is show this deeper theory projects into space-time and gives me back evolution by natural selection. And now that gets back to what, there's a long way to get back to what you were pointing out about the notion of entropy and time and so forth. So this deeper theory of conscious agents, it's a Markovian dynamics in the version that we're working on. And it's possible to create a dynamics in which the entropy does not increase. It's not zero entropy. You know, I know you were questioning on that. It's not zero entropy, but it's constant entropy. So the entropy is not increasing. So there's no arrow of time, entropic time. But it's a trivial theorem to prove, three-step proof, that when you take a Markovian dynamics, in which there is no arrow of time from entropy, and you look at it from any perspective by conditional probability, projection by conditional probability, then you will induce an increasing entropy. When you take that dynamics and project it onto it, so you're projecting onto a new dynamics, which is smaller, it's a projection dynamics. And in that dynamics, entropy does increase. So right now we see a world of increasing entropy because that's an artifact of a projection. We're not seeing the whole story. Because we're not seeing the whole story, it looks like entropy is increasing. So time ends up being not a deep insight, at least entropic time is not a deep insight into reality. It happens to be an artifact of our interface. And so that then gets back to the theory of evolution by natural selection. Theory of evolution by natural selection is, of course, about how the arrow of time is affecting the evolution of organisms, right? You know, and I have to compete with you for resources and have offspring, and we're trying to fight entropy, increasing entropy all the time. That's why we have to eat. So that whole story of evolution by natural selection may be an artifact of a projection of a deeper theory in which there are no limited resources, there is no entropic time, and there's no competition. Maybe it's all cooperation. But when we take that deeper dynamics of consciousness and project it by conditional probability, we necessarily get the arrow of time, of entropic time. And so what would be beautiful, I would just love to live long enough to see this, is how a theory of conscious agents with no competition, no limited resources, when you project it in a particular specific way, you get exactly Darwin's theory as the view from the interface. That would be just a stunning unification where we where we see all the, because evolution by natural selection is an incredibly powerful theory. I've used it in my research to make predictions about features of the human face that affect people's judgments of attractiveness of human faces. So I use the theory of evolution by natural selection with my graduate students, Darren Peshek, for example, and other Nagar Samak Najad did her PhD with me on this as well. And what we did was we used evolutionary theory to actually predict experimental outcomes about what people would find attractive in the human eye. And we would then go and do the experiments and confirm that the evolutionary predictions were in fact correct. So it's an incredibly powerful theory. And yet, I'd love to have this deeper theory that shows that evolution, as powerful and as beautiful as it is an artifact of projection of a deeper theory. And that's the beauty of science. We can actually enjoy Newton. Newton is an incredibly beautiful framework. It's wonderful, and it does a lot of good stuff. Now we can enjoy Einstein's space-time and his theory of general relativity, gravity, and quantum field theory, and enjoy that for all it is. And evolution by natural selection, those are incredible theories inside of our headset. And then we can go beyond the headset and look at all these conscious agents interacting and say, here's how we create this headset. And if we create this particular headset, notice we get Einstein's theory and we get evolution by natural selection as the view that you would get from within that headset. That is a beautiful way to think about science, because as we transcend a theory, we're not throwing it away. We honor Newton. Newton's theory is wonderful. It's a wonderful theory. And we can see it as a special case or a limiting case of Einstein. And then we can think of Einstein and all of space and time as a projection of an even deeper theory of conscious agents. So the theories aren't, as we transcend them, we don't lose them. We don't lose respect for them. We have the greatest respect for Newton and Einstein and all the work in space-time. And as we go beyond, we will have a deeper view of these theories. We'll know that the theory of gravity and quantum field theory and evolution by natural selection were just headset theories. They're not deeper than that, but they're beautiful theories, and they let us transcend the headset, to step outside the headset. Okay, the spiritual people may have been telling us for thousands of years, but hard-headed people like me wanted a theorem.
Yeah, of course.
We would like a theorem, and now, for better or for worse, kicking or screaming, we now realize that space-time isn't fundamental. We thought it was, but our best theories now come back and punch us in the face and said, you wrote this theory, and your theory comes back and says space-time is not fundamental. Okay, you can either throw away your theory and all your work, or you can say, well, I'm going to accept the verdict of my theory that there's something beyond space-time, and then jump in with both feet, and that makes it fun.
Yeah, that's a great way of describing this phenomenon. And it like you had said, it's not the discarding of these previous people. It's like it's famously stated, it's the you're still inevitably standing on the shoulders of giants, no matter what you're doing, because you're framing. You go all the way back to Socrates. I mean, the natural sense of science and inquiry originates in the thought of Socrates with the idea of inquiry. So you're always essentially standing on the shoulders of these giants, regardless of if you've dispensed with some of their stuff and not others, or have put them aside. Like you had said, it's an integral headset to have worn at some point, to have wear the one you wear now.
That's right. And that does fit well with the idea that consciousness is just exploring all of its possibilities and putting on different headsets, and it learns stuff in the headset and wakes up and goes away sort of enriched by the experience of being an Ethan Ivey or Donald Hoffman or whatever avatar it happened to wear. It enriched through that experience and or by being a junkie, and a drug lord, and it's tried all these different roles, and you take your headset off and you learn something about your possibilities as consciousness from that as well. So it's exploring the good, the bad, and the ugly.
Absolutely, it is, and it's neat to think about that in like psychologically as a Carl Jungian type perspective, because he framed the world in his psychological perspectives in analytic psychology around the idea of archetypes, that are subconsciously embedded into the fabric of being. And so these archetypes naturally resurrect them. So it's like consciousness takes on archetypal representations in different ways, like you said. And Carl Jung, the way he talks, seems to mesh a little bit with that. Like he was analyzing the psyche, and when he split with Freud, it took this psychoanalytical perspective and furthered it deeper into that arena of, well, it seems like consciousness reappears on the scene in different life forms, but they always take on these particular archetypes. That's interesting.
That's right. And those archetypes, there could be at least two different sources of those consistencies with those archetypes. And one might be that they're properties of consciousness qua consciousness, or they may be properties of consciousness qua consciousness only when it's wearing this kind of headset. So the space-time headset and the particular kind of parameters of that headset. So it's hard to know, is it the real fundamental properties of consciousness, or more contextual ones based on the particular headset? And maybe both are involved in what Jung calls archetypes. But that's be interesting. And again, to answer these kinds of questions, we'll need to have the theory of conscious agents and the theory of the projection, and then we can begin to say which of these archetypes are tied to merely the details of the projection, and which are beyond the details of the projection, are really truly fundamental aspects of consciousness in its own terms. So that
no, absolutely. And it's kind of like maybe like a map or something. It's when you look at a map and you see California where you may be, and Texas where I may be, and you can see Texas there on the map, but you're not in Texas. When you get to Texas, you can see just where you're immediately at in Texas, but not the whole state like you do on the map. And it's almost like, you need these ultimate maps, right, by which to proceed through the world with, and you have to have different maps. I mean, you see the ocean, well, then you get to the beach and you see it now. Now you see it in person, but you're not in the ocean yet. It's these little maps, and so eventually you default to, or at least myself, to philosophy and then to religious texts as ultimately the ultimate map, maybe the transcendental map, that which objectifies the good, the true, the beautiful, and stuff like that.
Right. So I'm very interested in the dialogue between science and spirituality. I think that the spiritual traditions have, for thousands of years, been saying that space-time isn't fundamental. I think so. I think they've had some insights. And as a hard-nosed scientist, I also think they probably have a lot of nonsense as well, just like in scientific theories. And so, but there needs to be a dialogue where the tools of science and the insights of spirituality are brought together, and we begin to forge scientific spirituality that's very, very rigorous and gives new, deeper pointers. I mean, spiritual traditions talk about pointers as being helpful, but not the truth. The Tao that can be spoken is not the true Tao, kind of thing. But I think science can help evolve better pointers and evolve them more quickly, and so there can be a real promising and beneficial back and forth between science and spirituality, and I'm all for that. Unfortunately, I have to leave now. It's been a couple hours. I need to go.
Sorry about that. I meant to try to conclude earlier. I apologize.
Yeah. Can I conclude with just a brief answer to one question that I get a lot, and it comes up for people a lot. People say, look, you used theory of evolution by natural selection, in particular evolutionary game theory, to prove that we don't see reality as it is. And if that, you say that therefore our senses don't show us the truth, but doesn't that also prove that mathematics itself is just a part of our headset, and so you've proven that there are no mathematical proofs, and you've shot yourself in the foot. So you've proven that there are no proofs, right? Because you've proven that all of our cognitive capacities, you claim some of the cognitive capacities, like perception, are not the truth. So here's another cognitive capacity, our ability to do math, and so you've shown that math is not an insight, and therefore you've shot yourself in the foot. And the answer is that the theory, the mathematics of our proof only entails stuff about sensory systems and nothing else. we have to do is look at every cognitive capacity one at a time and ask the evolutionary question of it. In the case of mathematics, there is good reason to believe that there are some selection pressures so I'm now using theory of evolutionary selection. There are selection pressures for some facility with mathematics. 2 bites of an apple offer me more fitness payoffs than 1 bite of an apple. This is not about truth. This is about fitness payoff. This is about something inside the interface. It's fitness, right? Not chopping off my hand is a good thing for fitness reasons, right? And eating 2 bites of an apple, realizing that eating 2 bites of an apple gives more fitness payoffs than 1 bite of an apple, which is elementary mathematics, is something that would be good to know from within the framework of evolution. So there are selection pressures for some elementary abilities in mathematics. I'm not saying selection pressures to be mathematical geniuses, but every once in a while, of course, the genes come together to come up with a David Hilbert or a von Neumann or someone who's a mathematical genius. Most of the rest of us have a hard time balancing our checkbooks. But again, my only point here is to just to take care of I get emails all the time from people asking this very, very same question. So I decided I need to put it out in the podcast just to say, look, there are selection pressures for mathematics, for mathematical ability, whereas the selection pressures are uniformly against any truth in our perceptions. And so we have to take a more nuanced approach to things. And so, I mean, it's a good question. It's a very natural. I think it's not a stupid question. So it's a wonderful question. It's an intelligent question, and you can see the answer requires going a little bit deeper. So it's no surprise that people wouldn't get it right off. But anyway, so I hope that will help some people who see this podcast allay one of the fears that they might have. So.
No, yeah, and I think I was able to capture throughout this episode or throughout our discussion a pretty solid understanding. I mean, from my simple mind, understand what you're doing with math and how it works. And I see the potential paradox that people could run into. But I at the beginning of our conversation, by the end of it, I could feel my cognitive state shifting to the way how this is oriented. It's a dynamic, intuitive landscape shifting viewpoint, and nothing wrong with that. The best viewpoints, generally the best thoughts come from that. But yes, I'm glad you clarified that, because over the conversation, I was able to slowly get into that frame. And I see now as I study this more, I'll be able to shift into that like I said, 2 feet in, or dive right in and just let go of the intuition. So I think you did a good job throughout the dialogue encapsulating that, but good point to end on for sure. And also I want to say thank you very much. I appreciate your time. It means a whole lot to me to be able to have this discussion with you, as I've thoroughly enjoyed your work, and I look forward to the future of it, as I'm sure it's going to be incredibly fascinating. And so thank you again for your time.
Thank you very much, Ethan. Thank you again for your kind invitation.
Absolutely. Thank you. You have a great day.
You too.
Bye.